I'm going to talk about microplastics, and then kind of why the University of Washington Tacoma? Why here? This is an international issue that actually started and really was built from the University of Washington Tacoma before the Center for Urban Waters was even built. So a couple of years before it was built. So I'm going to start with this video here. Is this a touch screen? Oh, it is perfect. I like to start with this video. This is just a picture, and there's just, bubbles happening here. But this is a scuba diver. What are those things, those sticks called? Selfie sticks. He's got his little selfie stick out, and he's just swimming in Bali. And he's swimming in a lot of trash. And so in many countries, and even here in the United States, for years we used to just how do we clean off the land? We would just put it in the ocean, right? And there's still countries, even in New York City, within decades, just a few decades ago, we stopped dumping our trash out in the Atlantic Ocean, right? And so there's places, you use this manta ray, which is kind of apropos because we use a manta net to do our research. But anyways, you can see all this trash where in many places, I went to the Virgin Islands and they have these places called guts. Those are just basically like little valleys that water just runs down into the ocean, and that's where they would put their trash. It would just go into the ocean. This was just like a couple of years ago, okay? And as we look at this, we've got, look at that, it's amazing. On top of him is a bunch of trash, but also sea life. There's sea life that's up there, and it's definitely something to think about, and I need to make sure this stops, because it'll keep playing on, and all of a sudden weird things start to happen. You guys know this. I'm gonna get rid of that. Okay, and I'll get back to my PowerPoint. So plastic pollution in the ocean. So this is one thing that you and I are looking at it going, that's gross, but it's real, okay? This is real stuff that we're seeing out there. So again, why the University of Washington Tacoma? In 2008, so just a couple of years ago, yeah, a long time ago, we actually hosted the very first International Marine Plastic Debris Conference. Were you guys around? Were you around, Dane? You weren't around there. Were you here in 2008? You got Julia? Yeah. You were already gone. Yeah. I keep bringing back history oh my goodness. 2008, we hosted the first conference, okay? And what we did at that conference is that's the meeting where we defined microplastics, right? And so that word microplastics back in 2008 was just kind of a misnomer. It was used before. We didn't invented it, but we actually formalized this idea of any plastic or any polymer that's less than 5 millimeters. That came from that conference at UW Tacoma. A couple of years later, we basically came back together and we wanted to figure out the so what. So what? There's plastic in the environment. Who cares, right? And so that was the second meeting that actually happened in the Center for Urban Waters before anybody moved in. So the Center for Urban Waters is basically, it used to be the Puget Sound Partnership, University of Washington Tacoma, and then the City of Tacoma's Environmental Services was all in that building. But we had the meeting before anybody moved in, which was kind of cool. But now it's a pretty active building right now. So during that very first conference, or that meeting, the NOAA came up to me and said, hey, Julie, can you tell me how much plastic's in the ocean? No. But what they really were asking us to do, which was really fun and cool, and Dana had a chance to work with us because we were a bunch of nutsos, is we actually developed methods that are used internationally today all over the world to collect and to identify and to quantify microplastics in the ocean. Okay, they're still using our techniques. I didn't do anything. It was all the undergraduates that were all doing creative things. I remember walking into the lab going, there was different colored solutions, what is this stuff, and I'd see things bubbling over here, and I'd see messes over here, and they figured it out. It was these undergraduate research students from the university. There were some researchers that were there, and also graduate students that figured it out, and they created this method that we use today. So since then, it's pretty cool. I think it's pretty cool. Shelly, that's what we're doing in the lab. So Shelly's one of our advisors for our program. That's what we do. We're creative. We get to go do really cool stuff. I worked with Kathy and her middle school students. These guys, I have to tell you this silly story, but these guys were so excited about this plastics research over at the middle school in Tacoma. And they actually went to the city hall and they're like, no more plastic bags. And they're like, the adults are like, okay, no more plastic bags. You know, like they were the ones that initiated. It's these young people that take care of this business, right? And they make me look really good. They make me look, I get called to do a talk at Cocktails and Fishtales, you know, it's pretty cool. So some of the things I've done is I've engaged well over 100, this is old data here, but well over 100 undergraduate and graduate students. And also collaborate with people not only within this region here, but throughout the state, the country, and even the world. I get to travel all over and talk about plastics, which is really kind of cool. Okay, so here's your lesson. Thanks for listening. But here's some research. Here's just a little bit of lesson about what are plastics. So plastics themselves are polymers. Okay, carbon and hydrogen, they're linked together. Okay, they're bonded together. The other things are added to it to make them different colors, make them see-through, make them bend, make them brittle. Okay. And so when I was asked to figure out how much plastic's in the ocean, I wanted to figure out like which one, because there are volumes and volumes and volumes of different polymers that exist. Okay, so this basically, the United States is basically produces over 20%, this is a little old, over 20% of the plastic. And this is primary plastics. It's used maybe once or twice and then thrown away, not reused. Okay, so that's the manufacturing of plastics themselves. When we look at the diagram over here, we see a circle. Okay, it's a pretty cool graph, right? On the inside of this graph is a gray kind of circle. Do you guys all see that? And then we see the green circle. That green circle is recycled, reused bioplastics, right? All that other, over 80% of those plastics, okay, those are the ones that are manufactured to be used and then not reused again. That's each year. That's a lot, okay? So we manufacture, in 2021, is 390 million tons of plastics were manufactured. That has gone up to about 420 today, okay? Because I just did a talk at Ocean Week, and so one of my research friends, they updated me with some new values, okay? But when we're trying to figure out which type of plastics, we focused in on these ones. And these are the ones that are most manufactured, the most used, okay? So the first one's polypropylene. You've heard of that, plastic line. Polyethylene, those low density, okay? There is PVC, polyvinyl chloride, okay? Polyethylene high density, and then polyethylene terephthalate. And Laura, we went out on boats, didn't we? Did you come out and play with us to try to figure out the method stuff? Yeah, so Laura was out on boats with us trying to figure out how to collect these samples in the field with the city of Tacoma's boat. And I remember we were using this line that was yellow. It was made out of polypropylene. My samples had a lot of yellow plastic bits in them. We had so much fun. We were like, go faster, go slower, no. It was really fun. Anyways, I had to add one more polymer. What do you think it is if I work in the ocean? Looking at this screen.
Fish nets.
Yeah, well, that would be the propylene. Yeah, that's what's that?
Nylon.
Fleece. That's also clothing. Yeah, it's polystyrene. Styrofoam, right? So when you're in the ocean, there's a lot of styrofoam. It's either coming from coolers, docks, those kind of things, but there's a lot of styrofoam. So I had to add this in here, this polystyrene. Now, interesting enough, there's two polymers on here that sink. Okay, one's polyvinyl chloride. It has a higher density than water. And the other one, actually, believe it or not, is polystyrene. Polystyrene has a density that's higher than what water is, and even salt water. Salt water's got a little higher density. It doesn't really float, but it does float. Why does it float? It's got a lot of air in it. Yeah. There's a lot of air that's blown in there. I mean, think about ships. Ships, they still float, and they have higher density than water. So we're really focusing on polypropylene, polyethylene, polyvinyl chloride, and polystyrene. And then polyethylene terephthalate, that's what water bottles are made out of. So there's a lot out there. So during that 2008 meeting, we also wanted to define what plastics were. We understood about marine debris, plastic debris. We understood the big stuff, the stuff you could see, plastic bottles, bottle caps, cigarette butts are kind of put in there too. But we didn't understand the small stuff, and so we came up with this kind of division of sizes. So megaplastics, anything that's bigger than the palm of your hand, okay? There are these macroplastics, palm of your hand, and a thin pencil. And then that definition of a microplastic, officially at that meeting, was anything that was less than 5 millimeters, but I put a bottom dimension because the 330 microns, or 0.33 microns, was the size of the width of the little holes in my nets that were collecting things, okay? And then anything that went through the net, because these guys were always asking about, what about the stuff that goes through? Let's just call it a nanoplastic, okay? So, microplastics is what I focus on. Anything that's within the width of a pen and the width of a pencil, and that's our microplastics. Yeah, it's the same picture as I used 100 years ago, Dina. That's okay. All right. But then the chemists got involved, and the chemists were always there, okay? We always need to figure out that so what part. So what? There's plastic. How many folks have eaten plastic before? Please, everybody raise your hands, right? And there isn't harm coming to you, right? Because we are physical beings. When we ingest things that we don't need, we just digest it. Is that the right term? I don't do biology. But we excrete it out, just to be polite. So for the most part, it's okay. It's cool. But the chemists were coming in because they wanted to figure out the things that were really, really small. Okay, and they were trying to figure out the so what. What's the chemical interaction that these microplastics have on organisms? And not just us, but plankton, worms, of course, the whales, and the salmon always gets all the money. So they came in and they redefined this size fraction from being from 5 millimeters to 1 nanometer. Anything less than a nanometer would be considered a nanoplastic. Okay? And so that's cool. I don't do toxicology work, but I have lots of friends that do that. I have a lot of friends that have convinced me that there's harm that potentially could happen when you're exposed to microplastics. Also during that meeting, we're scientists, right? We're environmental scientists, and we borrowed some terms from folks that were studying pollution, okay? There's two types of pollution. There's many different types, but there's two main types of pollution. There's primary pollution, there's secondary pollution. Primary pollution, you release gases into the atmosphere, CO2 gas, right? Sulfur dioxide. If sulfur dioxide links up with water, what does it change into? Sulfuric acid, acid rain. So the same thing, we use those terms based on that, looking at primary plastics. Those are the small pre-production plastic pellets. I like to call them nurdles because it's kind of a fun word to say. Those are the ones that we see. They're little buttons. Sometimes I've heard them called mermaid tears. Okay, those are primary plastics, and secondary plastics is the one that break down from larger pieces of plastics. Okay, so we have primary and secondary, and I think the next slide is actually going to talk a little bit. No, it's in a couple of slides, but I'll talk about them in just a second. So, well, let me back up. No, it's right here. So we have this primary and secondary. So I have this table here for primary and secondary. Now, the literature says there's 50% primary and 50% secondary plastics that we find in the environment. I would argue from my researchers who've done the work that we rarely find primary plastics. Most of it's broken down smaller pieces of plastic. Most of it, at least 99%, are secondary plastics that are broken down from bigger pieces. When we find nurdles, which is a sad thing, but when we find nurdles in our lab, we're like, yeah, and we collect them, we put them in vials. It's kind of like a little treasure, But we don't see them very often. We do see them on beaches, though. So if you've done some beach cleanup and that kind of stuff, we do find them. And if I ever get the privilege to hang out with you guys on a Saturday or a Sunday and look at beaches, I'll show you all the nurdles and pre-production plastic pellets out there. So I would argue that all of the plastic comes from land because it comes from us. I can say that plastic pollution, that's the only kind of pollution that we can say for sure that was you and me that put that plastic there, right? Because it's only humans make that. There's not plastics that have broken down from, a seal, right? Or a whale, okay, or maybe even a little plankton guy, right? Plastic pollution comes from humans, so I would argue it all comes from land, but there's this, in the literature, it says there's 50% comes from land, 50% comes from the sea, okay, because they're on boats that started on land, right? And I think the next slide shows 80-20, but we see it about equal. Sources for plastic pollution comes from the air. In fact, I would argue that a lot of the fiber material, the little fibers that come off of these, cute little sweaters, dresses, right? That's made out of, has these little fuzzies, they go into the air, and they make their way all the way to the glaciers at the North Pole. In fact, I did this interview with NPR, and it was all about finding plastic up in the Rocky Mountains on their air filters. I'm like, I'm not surprised, And then the other thing they said, hey, Julie, did you know that they found microplastics in human feces? This is a live interview. And I'm like, I'm glad that you found it in feces, right? Because that means that we digested it and it didn't stay in our bodies. I'm not surprised at all. But they talked about all this air fibers, and then they had to talk about human waste. I'm like, all right, moving on. It was really weird. I took this meeting in my car in the Pinkerton parking lot at school. I was like, oh, here we go. So it was this national thing. But the thing is they were really thrilled to hear about all of this plastic coming from the air. But I'm not surprised, right? Air moves. We expect it to be in water, right? And maybe a little bit on the land. Of course, just look at gutters, right, on their way to the ocean. But air, people don't think about it. And that definitely is a large source of some of the really fine fibers that we see in our samples. The last thing, of course, are sediments. They're in sediments. And I'm actually a sedimentologist. So I study sediments all over. And the bottom of the Puget Sound, the Salish Sea, all over the world. We bring it up to the top, and we look, actually, underneath, Highway 16, we look at the sediments that are coming off this Highway 16. That's what these guys are doing. So when we look at this picture here, this is a really good picture that Noah created just to figure out the sources. But if you've noticed this, all of the sources come from land. Okay? So we've got water is going to bring it in, wind and water is going to bring it into the ocean. Sometimes it's done on purpose. Okay? Sometimes it is done on purpose. So there was a huge tsunami, right, that happened, and all of a sudden you go back the next day and all of that beach was cleaned up. Why? Because they just put it into the ocean, right? Sometimes it's unintentional. You go to a really cool kind of an activity. You have a lot of people in one room hanging out, drinking wine. Is it good? It's good, huh? Yeah, it's delicious. Right? And you have too many people, and all of a sudden the trash is too full. So what do you do with your trash? Just leave it right next to it, right? That's another way to unintentionally, not on purpose, but maybe that's how it can get into the environment, right? Would I take it home? I don't know, it depends, right? So here are some of the ways, and mostly can get into the water, and it can start kind of bobbing around, and then finally kind of break itself down into these microplastics, okay? We see the entanglement, I think the whale's kind of cute, but the entanglement of the whale and the fish nets. You guys were talking about the fish nets, right? So we got the nets there. How many folks have seen that poor little turtle, the straw in its nose? Yeah. It's the same turtle, but sure sucks, right? Right? And then also there's a great picture of, I think, turtles eating plastic bags that look like jellyfish, right? Those kind of things. So there's a connection there that you and I are like, oh, that's not good. That's not good. Not sure exactly how it's harming those organisms, but I'm sure it's just definitely not good. What else do I want to show? Oh, commonly found plastic. So here's a little quiz for you guys. So we got cigarette butts, bottle caps, straws, plastic plates, plastic bags, of course. It looks like that's a candy bar wrapper, I think it is, and a bunch of bottles, right? Where do you think they got that data from? Which one? Yeah, there's one big one. Happens on Earth Day. the international coastal cleanup, right? And maybe you guys add that to that data set, but there's a huge data set that's out there that every Earth Day, you'll see people on the beaches and they collect all of this stuff. So a lot of this material comes from this, or the data for what we're seeing here is coming from that international beach cleanup. Yeah, good. Good job, Kathy. That's what she does. Yeah. All right. So who cares, right? Who cares? What is the fate and the transport, right? What is the fate and the transport? So here's the picture I was telling you about. This is from Paul Pont et al. From 2018. He would argue 80% comes from the land, 20% comes from the sea, mostly from cargo ships and things. How do you think we get plastic? I'm trying to think of a good question. What's the source of the plastics? It's not done on purpose, but majority of it gets into the ocean. What do you guys think? Yeah.
Landfills?
It could come from landfills, yeah. So if they're not sealed up, if they're not they call those sterile landfills. Yeah, Phils, yeah. How else? Littering, yeah, yeah. Rivers, yeah, sure. Runoff. Okay, of course the air.
Cruise ships.
Could be from ships, cruise ships. You know, I've had some students we have a lot of veterans that come to the University of Washington Tacoma, and I've had some veterans say that, we would just throw our garbage over.
That's what I'm thinking.
Yeah. But then there's other veterans who said, no, I had captains that wouldn't let that, because it's against the law, the international law, right, to put plastic in the ocean. But some captains are like, just throw it over, and other ships would be like, nope, can't do that. But I think that's kind of cool. So let's talk a little bit about the fate and the transport. Oh, I know what I want to say. So how did it get into the ocean? Well, here's what happens. How many folks have made a cup of coffee this morning, a pot of coffee? Right? And you scoop out those grounds. Do they all make it into the basket? A couple fall. Right? Yeah. And every once in a while you hit the end and it's all over the thing. Right? But it's like, think about all the 1 or 2 or 3 or 4 pieces of plastic pellets as you're transferring it from one location to another that falls out. Okay? Imagine a manufacturing floor that's got a couple of pellets on it, and you walk across that floor. You're going to take that out to the parking lot, right? And then you have a rainstorm in the rivers, and then that's how this can move itself into our waste stream, or into the streams and into the ocean. Okay? I remember driving to the Center for Urban Waters, and there's this manufacturing place that had this huge train that was filled with plastic pellets. It wasn't even contained. And they were scooping out the pellets, and as they moved it from here to here with their big loaders, stuff's falling down, right? So it's that transfer from one location to another that's the problem, which it's not intentional, but it's the accidental. So excited. Battery is dead. Dead battery.
Spare one?
Spare teacher points. Yeah, luckily I teach cycle, so I'm here to get you guys really motivated. Let's go. All right. So anyways, what was I talking about? I was talking about unintentional. Yeah, unintentional ways in which these things get to the environment. I don't think it's done on purpose. But what was interesting is when the plastics industry, the manufacturers of these pellets were told about it, they said, oh, we didn't even think about it, right? And so they actually did a really good, it was probably 2013, where they actually did, and they changed their manufacturing processes so that they lessen the impact, okay? So I thought that was kind of cool, right? But there's still opportunities and there's still chances. Sometimes, boats sink, and sometimes they actually get into the ocean. Yeah?
So these pellets are manufactured pellets?
Yeah.
These are used for making other things?
Yeah, your glasses.
Okay.
So they melt them and then they put them in injection molds, and they're little.
So it would be to their, it would be advantageous for them to have less waste.
Exactly.
Yeah.
And so they really felt that the consumers were like, no, this isn't good practice. And so they definitely they made a lot of changes for the overall industry, which I think is great, So people are listening. So let's talk about the fate and transport. So when a polymer had a brick and a piece of wood with nails in it that was floating on the surface, right? Because if you have a current that's going fast enough, it can keep things going for a while, right? So the buoyancy, we can actually move that plastic pretty far out. And what happens is that plankton, they eat everything. Yeah, thank you so much. Woo. Yay! Plastic can eat anything. No, plankton, they just eat all the time, right? They're just eating whatever. They're just moving water in their mouth, and they're going to eat anything that's solid, right? So they're eating that stuff up. So there's this transfer of this plastic material into these organisms. Now, do they get stuck in there? No, they poop it out, okay? They actually do excrete it, and then they create pellets. And guess where those pellets go? All the way down for us to pick up and talk to you guys about it. So that's a way we can get this buoyant stuff down into the sediment, okay? Have you guys ever had like a plastic chair that was outside for maybe a year, and then it started turning green? You know, that's biofilm, right? Biofilm, things start to grow on things, especially in the Northwest. It's wet. Right, thank you. It's nice and wet. So biofilm actually can stick to plastics. In fact, organisms love to kind of take up any kind of real estate. Anywhere they can land, they're like, this is cool. I'm going to live here for a while, right? I'm going to multiply. And what that does to these polymers or these plastics is it causes them to also sink. Okay? You can imagine if you had these biofilms moving across oceans, potential for invasive species, right? So changing things and bringing things from one location to another. Organisms also can kind of break things down. Most of the breakdown of plastics is mechanical, okay, wave action. The sunlight, okay, think about those blue tarps that sit on top of people's, in their homes, in their yards. Eventually they start to break down. Not really from the sun, or from the wind, but it's from the sun that starts to break those things down, right? So we have that breakdown that way, okay? They start to break down, and then they continue to make their way down to the ocean floor, okay? Some plastics just basically, we call it sedimentation. They're heavier than water. They get out there, they make it down. We have this little rack there. We're just pretending like that's a shellfish farm. Okay, so again, shellfish, they're filter feeders. They're eaten, right? In fact, a lot of my students who work in the shellfish and the fishing industry, I remember them changing to tell me, hey, Julie, I have to clean out the fish and get rid of all the plastics and the guts before we can send them over to different countries that are buying our fish because they don't want plastic in there. That was a big change since I started teaching at the university 20 years ago. Okay. So we get sedimentation in the fish farms, also just the natural farms of the shellfish, okay? Now again, if you eat plastic in a shellfish, it's probably not going to harm you too much because you know what's going to happen to that plastic. But imagine what's happening, what kind of chemicals are being transferred to that organism, okay? And that's active research that's happening right now. All right, and then we have the benthic organisms at the bottom. So there's those little worms, we have some brittle stars, we have these poor little crabs. They're just resuspending, so now we're just moving things around again to go back into the cycle, okay? Then we find worms, we open them up, and there's plastic in there, okay? So that's where these things are going. The last thing I wanted to talk about is the transfer of chemicals. So plastics themselves, they were made to be tough. They were made to replace bricks, wood, you know, most of our natural resources, that's what they were made, to be very durable. Some were made to kind of break down too, but they had a purpose, okay? But what causes harm is not the plastics themselves, but the plasticizers, things that make them kind of bendy, different colors and stuff. Those were additives that were added. Some plastics actually have a coating on it to prevent organisms from growing on there, right? So those are potential pollutants. Those adsorb, they stick to the plastic, okay? Plastics themselves, actually I'll ask this question. What happens when you have a spaghetti dinner? Nobody washes their dishes by hand anymore. Does anybody still do that in here? Okay, a couple of us. Okay, cool. You guys reflect with me. So you're out, you're making dinner. You go to wash the dishes. You had spaghetti that night. It was delicious. And all of a sudden you have this plastic container you forgot to wash. And it was at the end of the washing cycle. And you put it into your dishwater, and what happens to it? It turns red, it turns oily. Plastics themselves, polymers, are called hydrophobic. They don't like water. Oils also are hydrophobic. They love to stick to plastic. Okay? So when you have plastics in the water, especially in industrialized areas, you can have these organic chemicals, these organic materials actually stick to it. We call it adsorption, not with a B like a sponge, but a D. It sticks to it, okay, and it can actually absorb all of those pollutants. And so there was some studies from folks in Japan that took a bunch of plastic pellets and started analyzing and looking at the concentration of these pollutants, and they saw that there's 3 and 4 and 5 orders of magnitude greater concentrations of pollutants. Here's the catch, though. Here's the catch. There's this thing called electron affinity. I know you guys are like, organic chemistry again, or environmental chemistry. No, but there's this electron affinity. This happens with these molecules where once it bonds, it stays there. It sticks really hard. It doesn't want to just slap off and transfer it to organisms, right? So it's actually kind of a good thing. I'm not saying do not put plastic in the ocean to try to clean up the pollutants, but it actually is kind of a cool thing. It actually will stick to it, and it may not be able to transfer that to other organisms. That's kind of cool. The organisms just floating around the water, that's a whole nother story. They're on their own. But the plastic they ingest maybe doesn't help transfer those pollutants to those organisms. All right, what else do we want to talk about? I think I got it. Any questions about this? We'll have a quiz we have a quiz tomorrow, but you guys will have a quiz on this in a couple days. So Will's got a quiz at 8 a.m., so it's on Metamorphic Rocks, but go ahead.
Checking if you're interested in sedimentation, like Bay.
What my focus, my research focus, and I'll talk about it in just a little bit, is just originally was we didn't even know what was out there. So really what my focus is to work with my undergrads to figure out how are there plastics in the ocean. We knew that they were, but how much? And so it was really trying to see if there were some or not. And then what we found is after hundreds of samples, right, that we found them everywhere. But not only, I started off doing water in the water column and then focusing on the sediments. And I'll talk about that project hopefully if we get some time today. Yeah, I saw a hand over here.
We just wanted to hear what the question was because we couldn't hear it over here.
Oh, just what the focus of my research was. Yeah, sedimentation and stuff, but not really. Yeah.
I kind of gathered that.
Yeah.
Start answering.
Yeah. I'll do that again. In the back there. Yeah, you had your hand first.
The transfer of chemicals, you said there's research ongoing now.
Mm-hmm.
What are they focusing on? Are they, is it that they break down eventually chemically?
Yeah, so that research, I'm just going to have you guys remember the Plastics Consortium. They're out of Oregon State University. I'm a part of that. So they're the group that runs that. It's an NSF group from Oregon State University. They're focusing on that, but they're mostly looking at doing lab experiments. Let's go ahead and feed them poison pellets. Let's collect organisms and see, what kind of plastics are in their guts. And these are small little small things up to shellfish and fish. And trying to see, do you see this chemical transfer? Yeah. So there's a whole lot of research, and that's beyond me. I wish I could do everything, but I can't. Yeah. Sir.
Are there any organisms or plants that actually successfully use microplastics to grow and thrive?
Yeah, there's an organism, there's a bacterium that they found that helps break down some polymers. I mean, there's going to be, yes. Is it successfully, and it takes a long period of time. Yeah.
Are they used in any pollution areas?
No, right now it's a little, of course, there's a lot of startups, and we met some of these guys at Ocean Week up in Seattle a couple of weeks ago or last month. But there's some people that are doing some cool, innovative things, but not really scientifically. Yeah. And they call me all the time, like, "Hey, Masura, what do we think about this?" I'm like, well, that might work. Let's play with it. So yeah, there's lots of really good creative ideas out there. Oh, there's my bigger picture. Moving on. So who cares, right? So again, I was telling you guys about the 2008, that's where we're defining things, trying to figure out what we knew, what we didn't know. It was really fun. I got to do a talk like this at a bar. It's called the Swiss. It's gone now. It's sad.
That's such a great place.
Yeah, kind of sad. But, you know, moving on, right? They just closed down the Rock 2 weeks ago, which is a pizza place that was right next door. Anyways, back to you guys. So during that time, we actually were talking about, what do we know, what we didn't know. Got to meet these really cool people. And then the second meeting was the so what, because we're like, okay, yeah, we all found it. Yeah, it's there. It's cool. It's there. It's bad, But who cares? And so we're trying to understand the so what part. And this is the active research that's happening right now. When I talk to students, and heck, all you guys, if you guys want to start answering some questions about microplastics, it's trying to figure out the so what. Because again, I think I eat plastic all the time, not on purpose. I don't eat straws or anything. But but I know I'm pretty cool. I'm pretty safe. But what is the so what? What's the chemical transference? You keep hearing about it's in babies. You find it in testes, the brain. I get those questions all the time. There's going to be a video that's going to come out that's going to be a public service announcement, and I do talk in that they're talking about all the things like the big so what part. But again, plastics were made to be low reactive, right? They were supposed to last forever. Okay, some of course were meant to break down, but for the most part, they were meant to kind of replace natural resources. The absorption and desorption, okay, so you can adsorb stuff, you can desorb, you can get rid of some of those plasticizers. But the impacts, I think, that I felt when I got into this research originally was looking at the macroorganisms, right? This is a baby chick albatross, right? If you go to the South Pacific, you're going to see a lot of this, right? Because plastic, when you eat it, you don't feel, you don't get any nutritional value. You just have this false sense of being full, right? And then in this organism, this poor baby chick, his parents was like, hey, look at that really cool red, food. I'm going to bring this to my baby chick and feed it to them. Well, it didn't move out of their bodies. You can see that their body just filled up with a lot of stuff. So it causes the guts to get clogged up and stuff like that. And that's what we're seeing here with this picture. So the question, the biggest focus of our research within my community, my research community, is about the toxic transfer. Again, beyond me, I'll go out and do all the cool field work. I'll prep stuff. But all that lab stuff, I'll let my colleagues, my chemists, take care of that. I call myself the analog chemist. Those things that are on a wall, they have a circle and they tell time. That's me. I'm not digital. All right. I just wanted, this is an old slide that I was like, oh, I want to find that really cool slide. And if I had, 10 hours to prep, actually it still says Jason Lee, sorry about that. But that's, so, but Jason Lee Middle School, that's Kathy and I, we did a lot of work. It was so fun. Oh my God. We used to do cool stuff. But these are some of the Tacoma Community College, Bellarmine Prep, USGS, Seattle Aquarium, North Seattle. It used to be a community college, now it's called a college. Sound Experience, you guys see that ship, that sailboat? How many folks have been on the Adventurous? Yeah, I'm on the board. So these guys have all been on the Adventurous too. Oh, Laura was just there a couple weeks ago. That's cool. Yeah, NOAA's Marine Debris Program. I had to go to the Virgin Islands and do research. And they paid for it. It was cool. University of Washington. NSERC is basically Canada's NSF. So I do a lot of work off of Vancouver Island. Did you ever go to Claquit? Oh, I gotta get you up there. All right. And then, of course, the Center for Urban Waters. So these are some of the collaborators that we continue to do work with, and I could add more and more. Okay. So what is the time? Where are we at? No, I was just trying not to. Where are you, Stina? What time are we?
Got 15 minutes.
Okay, cool. I can knock this out. Here we go. So one of the things I want to do is focus in on a collaboration, a partnership that I have with the Washington State Department of Ecology. And I have this with many different groups, but I like focusing on this one because this is a long time, since 2018 we've been working together. The Washington State Department of Ecology has the is a part, and University of Washington, actually, there's a lot of us that are part of the Puget Sound Ecosystem Marine Monitoring Program that's called PSEMP. Okay, and PSEMP is universities, jurisdictions, NGOs, just a lot of groups that just really want to understand more about Puget Sound. We've since been we're being kind of run by the Puget Sound Partnership. They kind of take care of the administrative stuff. But it's a really cool program where we all get together several times during the year and we talk about the Puget Sound and the research that we do. And so the direct partnership with Washington State Department of Ecology's Marine Sediment Monitoring Team, is that right? Allison's mom, but she's done that where she's like, stop it, Masura. but they work on this, they do this monitoring. So they go out and they collect 50 stations, just locations in the Puget Sound, and then they focus in on a bay. So one bay, 1 year might be Commencement Bay for 30 stations. That's just locations that they collect. Bellingham Bay, Bud Bay, Bud Inlet, those areas. So they actually do the collecting for us because that takes a lot of time, and they'll bring those sediments to our lab. And what I focus on and what I'll focus on for here is just giving you a little bit of the results because I'm a scientist and I got to show you some maps, of 10 of the stations that have been sampled from 2014 through 2024. Okay, so this is a GIS map, and you can see very poorly, I wish I had a, can I use a mouse? You can kind of see the mouse. But when you see a color change, here's a dark purple, and here's a lighter purple. When you go from a light purple to a dark purple, when you have the changes, the keys are on the bottom here, what we have is an order of magnitude difference, right? So if you go from one to another, there's 10 times more or 10 times less, okay? If you guys look at this map, it's kind of unremarkable. There's some cool things like, here's a fat dot from 2015, and then there's a a light dot. There's none in 2020 because no one wanted to take me out in 2020. I think they shut them all down. They're like, nope, we're not collecting there. I used to have a COVID thing on there, but I don't know what happened to it. But anyways, you can see here that over time, and then I've got a couple more maps on the next page, that there really isn't a lot of change. There's change, right? But it kind of goes back. So I don't see that when we look at a place that's kind of near Seattle or near Tacoma and Commencement Bay, we don't necessarily see an increase, we just see a change, okay? And if you look here, this one here, we got a 0. Now, I kind of want to redo that one. That's over by the Nisqually. But there's a lot of students that have done the work, and I don't know if that's really a 0, but we'll have to figure that one out. I might redo that one. But you can see that there's been a bit of change, but we don't see an increase. That's cool. Now, this is only 10 stations, and we have over, 50, we have 80 stations a year. But again, statistically, when we do the statistics, there's not a big change. That's cool. Or maybe not. Maybe, because when you talk about sediments, there's a lot of patchiness. So there might be a whole concentration over here, but you sampled over here because that's just where your instrument went in. So it's kind of hard to tell, but it really just shows that unfortunately we always have plastics. Unfortunately we do. But it's not getting bigger and bigger and bigger, okay? Here's the next couple of maps here. It's a little bit better. But again, we see this kind of the same thing. I mean, this is a bigger map so you can see, but you can see that for the most part, we've got about the same. There's usually between about 100 pieces of plastics that we find in each of our samples. How much do we collect? I don't know. I'm going to do it with my hands and put my microphone down. About this much. Okay, so we have this much sediment. We'll probably find about 100 or so pieces, right? Sometimes we find 10,000, but, who's counting? Well, we are. We're counting. Okay, all right. So just some of the facts. So we had none in 2017. Maximum was 27,000 pieces. Can you imagine that poor student? They're like, man, I cannot wait to graduate. Was that you, Dana? No, it wasn't. Dana actually, with her research project, she's my OG. She lives down the road here. But anyways, she had to take individual plastic pieces and then put them on this little teeny metal plate And then she had to turn this little thing, it's called a rocker, but it's just think of it as a screw. And you did FTR stuff, right? And then it had to go on this crystal, it had to be just flat, just perfectly, and then she got to push a button. And it would run 3 times. And then she'd pull it back off. Julie kind of threw, no, you gotta keep everything. So she had to put it back and please, no air, right? No sneezing, right? And then I think you did 250. That was her thesis, but good for you. Thanks for still coming and still liking to hang out with me a little bit. Anyways, 27,000 pieces, same year. The lowest average is about 600. Okay, that was in 2019. Highest, these are just cool numbers because I'm a scientist. 7,000, 2014. And again, COVID. I was hanging out with Stina on our laptops. All right. Focusing in on 2014, 21, and 23, 6,000. Okay, we found those in Hood Canal, which is kind of cool. Average per year was 680, 851, and 1421. And again, no statistical significance. Okay, we still see it. We're still concerned. We still need to continue to monitor, but we're not seeing an increase.
I'm not sure I would agree with that.
So the last thing I want to do is show you just a really quick video. This is a cool video I did with Washington State University's extension up at in Snohomish. But this is the what can you do? So this is a video I'd like to share with you. And I was telling these guys that I feel like it's Jurassic Park. Do you guys remember, like, hey, that's me? but I'll show you this video. Does this need to go?
I think the volume will work.
Should be. Oh, on the speaker. The Salish Sea is a beautiful place. It has amazing wildlife. We love our beaches, our mountains, our forests, the salmon, of course, our orcas. We see plastic quite a bit along our beaches, along our waterways, within our lakes. And there's even invisible or nearly invisible plastic called microfibers that can be transported within the air itself. Only a very small percentage of plastic is recycled. And of that, only a fraction is recycled properly. Plastic has the potential to harm wildlife. Small, lower trophic organisms like shellfish can mistake plastic for food. Larger megafauna like seals can become entangled in plastics. There are some solutions to reduce the amount of plastic pollution in the Salish Sea. The first thing you could do to prevent it is to never use plastic again. And that's not possible for the majority of us. But there are some other solutions that you can contribute to.
I do use some plastic bags, but I rewash them. I can use them over and over again, but my preference, if it's going to be disposable, are the paper bags.
When I go grocery shopping, I like to take my mason jar and fill up with my bulk items so that I don't have to use plastic bags or buy items from a bag.
When we're out as a family, we always bring our reusable water bottles.
Hola, queremos simplemente recordarte de que cuando salgas de viaje nunca olvides de llevar tu botella.
Siempre llévala contigo, reusemos y no usemos el plástico.
Our family takes reusable water bottles with us every time we leave the house, and I like these small reusable bags that fit in my purse, so I always have at least one with me.
So my personal project is to make as many beautiful bags as possible. And I gather all kinds of fabric scraps. So making bags as beautiful as I possibly can. And hopefully then we can tilt the balance away from plastic and more toward beauty.
When you do recycle, make sure that you check out your local guide, like the one I have here. And in the local guide, they actually show you shapes and colors and the types of plastic that can be recycled within your area. If you do choose to recycle your plastics, make sure that they're empty, that they're clean, and that they're dry. Here in the Salish Sea, we want wildlife here.
not plastic pollution. So let's work together to clean up the environment and make it a beautiful place for us and everybody that lives here.
Avoid that plastic, bring your water bottle.
I'm here to answer any questions you all have. If you have any more. I feel like my class though, we just keep asking questions while I talk, which is awesome. What's up? Yeah. Yeah, you. Sorry, sir. Yes, sir.
Have there been surveys taken on the microplastics, nanoplastics in food and fish, especially in the different countries, especially like the Philippines, China?
Definitely there is research that are happening in those countries. I do know that in the United States, we export a lot of stuff to China. And I was in Korea, and I remember being on a ship in Korea, and you'd see all these shellfish, or just even fish farms, right? And there's just like stuff floating everywhere, you know. But there's definitely kind of an issue. So is there research going on? Yeah. Are we trying to do better? Yes, for sure. Yeah. Yeah.
I think I remember early in the presentation, were you saying something about you do tests on the samples to determine what types of plastic you're finding?
Yeah, to test for polymers, we use this instrument called an FTIR. So basically it's an instrument that zaps infrared electromagnetic waves. It excites the polymer and then it re-emits these spectra. And so we look at basically a bunch of wiggly lines, and then just like a fingerprint, we're like, oops, that's polyethylene, that's polypropylene. And we did it, we actually did it visually when Dana did it. And then we actually automated, so it's actually done with a computer program. So they have libraries of polymers, and that's actually pretty easy. It's pretty simple. Again, that's analog. My other friends, they'll throw it in an instrument and they'll burn it at a really high pyrolysis is what's called, and they'll burn it and they'll discover the polymers that way. But then they run the sample.
So if I may tack on an additional question, I'm guessing there's probably no simple answer to this, but are there particular plastics that you like seeing less than others, if that's a way I can put that you hate to see more than others?
I don't have an opinion. I just look and I'm like, oh, cool, there's plastics. And, you know, I'm more, again, most of my research is all about description and what is and isn't. I'm not smart enough to know what's worse, right? Yeah, good question. In the back there. Yeah.
There's an increased interest in recycling, but there's problems with the lack of people that buy it. Well, the manufacturers didn't actually reuse it. And so a lot of times you think you're recycling, but all you're doing is changing which landfill it goes to.
Yeah, exactly. Recycling is really, the best thing that you could do, as I said in the video, is like, it's just not use plastic, right? And or to reuse and not just be a single-use plastic use, reuse things. You know, if I have to drink a water bottle, you know, I make sure I use it several times, you know. But it's just all about, what you demand. And if we don't want the manufacturers to have all the plastic and all that stuff, then we have to figure out a way to have them buy it back. But again, they can pay to put it into another waste fill or a landfill, right? Yeah, it's definitely the circular economy. I think we're doing better. We're having conversations. Again, we were at this think tank a couple of weeks ago for One Ocean Week, is that what it was called? And that was really cool because there was just like lots of really innovative ideas of trying to figure out how to kind of close that loop with plastics. Yeah, is that for me?
No.
She's off the stage.
Yeah, really cool talk. It's fun to see the kind of research that's going on in our local environment. I had a question about like the average microplastics that you're finding per year. It seemed like they were going up, but you said no statistical trend. Right. Were you using just standard p-values, or had you considered like maybe using something more, less of just like the arbitrary value of them?
Yeah, you have to imagine I have between 3 and 13 students come through the lab each year, right? So they're different people, the different students going in and out. So definitely we're just doing like standard stuff. And typically a lot of the, not a lot, but some of that research is just, 8 weeks in the lab and then I'm on to new students. So we really just keep it very basic. But I do have some really good friends that are statisticians that I want to sit down and like buy them dinner and just kind of nerd out. Because I think we have a lot of cool data. I just haven't, and it's all about time, right? Yeah, it's all about time. A good question.
So, with the multi-use plastics versus the single layer plastic, or multi-layer?
Yeah.
I mean, is there,
I mean, they can get delaminated, but I don't have really a lot of an opinion. The stuff that we see, I don't know, it's probably single layered. I don't know if I've ever seen something that was film and stuff like that. Yeah, but because we're getting stuff that's been down there in the bottom of the ocean for a while. Yeah. But even the stuff that are floating, I'm thinking out loud. But I haven't. Yeah, the layered plastic. I don't think it's not something I really remember looking at in the hundreds of thousands that we've seen come through the lab. Yeah.
Can you get a sense of how long the plastics that you collect have been down there? So what is the, if you land, what are you seeing, like, you're like the shortest to the longest? How long?
That's cool. As a sedimentologist, we can take cores, and I have cores that go back like 100 years. So in Quartermaster Harbor, I know it, like before the portage and after the portage. If you don't know that story, I'll come back and tell that story at another talk, right? But anyways, so with looking at, so I do have cores. Have I done that work? No. Could I do that? Yes. We can actually tell with the sediment itself by doing lead-210 dating. It's just an analysis we do in the lab. I can tell you how fast the sedimentation was done. But have I looked at plastic down core? No, it just hasn't. To be honest with you, I didn't tell you guys this at the beginning, but I actually get paid to look at harmful algae, which exists in the sediment, and this plastic gig is kind of just a fun hobby. I'm kind of kidding, I get paid to do it, but most of the work I do, so I do a lot of cores looking at harmful algae, what closed down beaches for paralytic shellfish poisoning. Laura and I did it, she did it as an undergrad. A lot of these guys have done this work, but that's mostly what I do. So I haven't looked at the plastic, I just looked at the organisms that are causing shellfish poisoning. In the back, yeah.
Is there any correlation between the algae and the plastics?
Ooh, I'm so excited you asked me that question. I don't know, but I'm going to ask, and I will come back and answer that question next year if you help me. Because I have students that are looking at chlorophyll. So I know, I'm not the actual algae themselves, but we're looking at chlorophyll productivity. And so that's another kind of data point that we're getting from the same sediment. So that might be kind of interesting to see if there is a correlation. Yeah, but just a one-to-one, it'd be super easy to figure out, but haven't done it quite yet. Yeah, I'll keep that in my pocket. Will you write that down for me? Sir.
Yeah, what is your view on biodegradable plastics?
Yeah. How many folks remember when those spoons came out, and you eat the soup and you're like, that was dumb. I think it's great. Here's the issue. It's like, okay, so if you're going to have stuff that's going to be bioplastic, it's got to be able to do what you want it to do, right? But it still needs to break down. Remember the sun chip bags? They had these sun chip bags that were biodegradable, but they had to sit out in the sun for 30 years, and you had to blow on it every once in a while. And so you put in your compost, and it would just stay in your compost because it was, it wasn't getting sun. Long story long. I think it's cool as long as it works, because consumers aren't going to buy into it and do it, right? But it's another option. It's another option. It just has to do better. And then you've got these things that are bioplastics that you put into your compost, but they don't break down. They have to go into an industrial composter. That's not what we put our stuff in. If you're putting it in your backyard, that's not good enough. It's not going to break it down. If I put it in my compost, I live in Linwood, it goes into the big, huge landfill up there that smells delicious in Everett. That's a good one. I'm good, right? So my opinion is if it works, then I think it's great. Yeah. It's just another alternative.
So the possible installation that sending out like the Alaskan seafood boxes.
Yeah.
You know anything about that?
Are you talking about the paper stuff?
It is supposedly made as
Like a cellulose, right? Yeah. Yeah. Sounds cool. I don't know a lot about it, but I do know that now there's also, they've got paper that they have it too, but yeah, I mean, it's better. You're supposed to be able to eat it. Don't eat it. Yeah, yes ma'am. Yeah, and we think about Patagonia, you know, their intention is still making synthetic clothes, but they're trying to make them better, you know. So that's a big one that probably came out, that Patagucci, they call it sometimes, right? Because it's super expensive. but trying to make fibers that won't shed, you know, because they're definitely, their fleecers are awesome and cool, but that they were one of the culprits. So it's just, yeah, companies, that's one I'm thinking off the top of my head, yeah, besides the pellet, the microplastic pellet industry. Yeah. Are we good?
Any other last burning questions?
Anything else? Oh, did I knock it over?
No, it's been knocked down twice.
Oh no! How did that happen? That's weird. Well, thank you guys so much for having me. It was really fun. We're doing it already, but another round of applause for Julie.
Thank you, Julie. Thank you, everyone. I hope you all learned something. Yeah. Did you all have fun? Yeah. Mission accomplished. Thank you for coming to Cocktails and Fishtales tonight, and we'll see you next time.